Video is about chemistry paper solved questions from Federal Board and KPK Board. The standard reduction potential for the following half reactions are two half reactions are given in which the copper, when it gain electron, it will produce copper solid, and chlorine gas, when it will gain electron, it will produce chloride minus. The reduction potential value is also given. Calculate E naught cell for the copper chlorine cell and write the cell reaction. So there is a rule: when the reduction potential value is low among two half cell, then it will act as an anode. So looking at these two values, 0.34 volt is low as compared to 1.36. So the copper half cell will act as a anode. So this is the reduction potential. In case of oxidation potential, the reaction will be reverse. So it is written as when the copper solid, it will dissociate and it will produce copper plus 2 and 2 electrons. Similarly, the sign of their potential, the reduction potential, is reversed in case of oxidation potential. So here it will be written as minus 0.34 volt. And the other reaction will remain the same. So chlorine, when it will gain electron, it will produce chloride minus, and it will act as a reduction half cell. So the value of this cell will remain the same, that is 1.36 volt. Now we will write the net reaction, but before we will cancel the electrons that are equal in number. So the net reaction is copper solid, when it will react with chlorine gas, it will produce copper plus 2 and chloride minus. In case of E naught cell, these both will sum up and it will produce 1.02 volt. So this is the value of E naught cell, and this is the cell reaction. The following experimental data were obtained for the following reaction at 250 Kelvin, and the experimental data is given in this table. Find the rate law that is consistent with this data, and the second part of the question is what is the value and unit of rate constant. So we will solve. Write the rate law that is consistent with this data. The data is given in the table. So first we will find the rate of reaction with respect to fluorine and the rate of reaction with respect to chlorine dioxide, and by totaling it or by combining these values, we will get the rate law. So first we will find these separate values. Fluorine, how the rate of reaction is changing with the fluorine. Looking at this data, this is 0.1, this is 0.1, and this is 0.2. So when we will move from 0.1 to 0.2, how the rate of reaction will change. So 1.2 into 10 to the power minus 3, it will change to 4.8 into 10 to the power minus 3. So by dividing the larger value to the smaller value, so 0.2 divided by 0.1, this is the concentration of the fluorine, and the rate, similarly the larger value is divided by the smaller value. So 4.8 into 10 to the power minus 3 is divided by 1.2 into 10 to the power minus 3. Solving it, we will get 2 and 4, and simplifying it, we will get 1:2. So the rate of reaction, it will change with respect to fluorine, and it is the second order reaction. Similarly, in case of chlorine dioxide, so here if we look at this value 0.01 and 0.04, if we change the concentration from 0.01 to 0.04, what will be the rate of reaction? So 1.2 into 10 to the power minus 3, it is changed to 4.8 into 10 to the power minus 3, which means that it is almost 4 times increase. So divide the larger value to the smaller value. In case of the rate, here we'll divide the larger value from the smaller value. So 0.04 divided by 0.01, this is larger value, this is the smaller value from the given data, and 4.8 into 10 to the power minus 3, this is the larger value of the rate, and 1.2 into 10 to the power minus 3, this is the smaller value of the rate. So here we will get 4:4. By simplifying it, we will get 1:1. So the rate of reaction, it will change with respect to chlorine dioxide as first power, which means that it is first order. Now by combining these two values of rate with respect to fluorine, that is second order, and with respect to chlorine dioxide, that is with respect to fluorine, that is second order, and with respect to chlorine dioxide, it is first order. By combining it, we will get the rate law. So the rate law is equal to, or the rate is proportional to, fluorine that has superscript 2 and chlorine dioxide that has superscript 1. Now change the proportionality sign with respect to K. So rate is equal to K fluorine second power, that is second order, and chlorine dioxide, that is first order. So this is the formula of rate law that is obtained from this given value. Second part is what is the value and unit of rate constant. We will find their value using the same table. If we look at this table, there are three readings given: reading 1, reading 2, and reading 3. We will find the value of rate constant using only one reading. For example, if we take reading 1 of fluorine, similarly we will take the reading 1 of chlorine dioxide, and the rate value will be from reading 1. So the rate of reaction has a formula that is K, fluorine that has second order, and chlorine dioxide that has power 1 because it is first order. So we will take the values from the value 1. So for fluorine, it is 0.1 but it has second power, and 0.01 for chlorine dioxide but it has first power. So 0.1 multiplied by 0.1 will produce 0.01, and the 0.01 for chlorine dioxide will remain the same because it has first power. Multiply these both terms, 0.001. Now we will find the value of K rate constant by rearranging this formula. So 0.001 will be shifted to the other side. So 1.2 into 10 to the power minus 3 divided by 0.0001. So we will get the value of rate constant as 1.2. Similarly, we will find the unit of rate constant using the same formula. So the rate has a unit mole per dm cube per second, and this is the concentration of fluorine. So it has unit mole per dm cube, but it has power 2, and it is also the concentration of chlorine dioxide. It is also mentioned as mole per dm cube with power 1. So first we will multiply this square with mole and dm cube. So mole square and dm cube will be multiplied with 2, so we will get dm minus 6, and the mole per dm cube will remain the same. Now if we multiply this mole square and dm minus 6 with mole per dm cube, so we will get mole 3, because here is 2 and here is 1, so it will become mole 3, and 6 and 3 will become minus 9. Now we will find the value, or we will find the unit for K by rearranging this formula. So mole per dm cube per second is divided by mole 3 and dm minus 9. So here dm minus 3 and minus 3 will be cancelled out. We will left over minus 6 there. Here it is mole and here it is mole 3. So if we cancel out 1 mole with this 1 mole from 3, so we will left with 2. So if we move this mole to the numerator side, so it is mole minus 2. And if we move the dm minus 6 to the numerator side, we will get dm6, and the per second is already in the numerator side. So the unit for K for this data is mole minus 2 dm6 and per second. pKa of acetic acid at 25 degrees C is 4.76. Calculate the pKb of conjugate base of acetic acid. We know that the sum of the pKa and pKb is equal to 14. So the pKb is equal to 14 minus pKa. The pKa is given as 4.76, so 14 minus 4.76, it will produce 9.24. So pKb is equal to 9.24.